Yes, so I think we are good to start. So let's start today's webinar on size matters. There's new consumer electronics for your fine line printing. Today's webinar will be hosted by Stephanie Limage, who's by two of us. That is Stephanie Limage, who's the head of customer pre-sales group, and myself, Rahul Ashok, the business development manager. Let's have a look at today's agenda. Today's webinar will be divided into two different parts. I would start off by giving you all an introduction on the company, introduction on consumer electronics, and we'll have a look at the market. Then we would move to further discussions with fine line printing applications, trends in the electronic industry today, and the various customer challenges. And then Stephanie, my colleague, would take it forward from here by entering into a more technical discussion on fine line printing, its parameters. She'll also be discussing on the customer case and challenges, ink-rheology, conclusion. And then we would have a short questionnaire. And finally, we would end it by a 10-minute session, a question and answer session. So for those who don't know much about GenesInk, we are a dynamic company created back in 2010. We are industrial leaders in providing nano-ink solutions and have more than 60 inks that are available at ton scale. We help our clients to design and create the electronics of tomorrow, and we also have a global team at your service with headquarters based near Axon province, sales offices in Paris, Japan, and Taiwan. Well, this is a quick glance at a young and a dynamic team here at GenesInk. Well, our mission is quite simple. Our mission is to design nano inks with functionalities at their core, right from particle synthesis to the very end printed product. I really like the photo on this slide because it clearly demonstrates how we help our clients. We help our clients to free up electronics that enable a new generation of consumer electronic products. In this slide, we are going to see what problems we solve and how we do it. So, as you all know, the next generation of electronic devices need to be smaller and more flexible. And how we do this is by controlling the entire value chain. That is, we manufacture the nanoparticles by ourselves, then formulate them into inks, and our clients then test the inks. Then we create prototypes, and we are able to further fine-tune the inks even further when required, and finally support the client until the very end production step. High power conductivity is critical in some applications, and the existing technologies in the market don't reply to this need. And our nano inks is 5 times more conductive than the market leaders out there solving various issues with regards to conductivity. Well, as you all know, existing traditional electronics create a lot of environmental issues as they're also operator unfriendly. And how we solve this issue is that we at GenesInk care a lot about the environment and sustainability, and all our ink formulations are non-toxic and non-cancerogenic products. Most of our competitors are only lab level. Well, even though we are a smaller company when compared to our competitors, we are able to manufacture a ton scale with no issues with repeatability and quality. Well, the 60 plus nano ink solutions that are readily available off the shelf today belong to 3 different product families, as you can see on the slide. Starting off with Smart Inks. Smart Inks is a range of highly conductive nano ink solutions based on nanosilver particles. And these inks can be used for various applications such as EMI shielding, antennas, sensors, IoT, in-mold electronics, etc. Then we have conductive inks, is a range of transparent conductive inks based on nanosilver wires. And these inks can be used for transparent electrodes and also acts as a direct replacement for ITO. These inks are currently available mainly for spray, slot die coating, and screen printing. And finally, we have Helios inks, which is a range of semiconductor ink solutions mainly developed for ETL and HTL layer of OLED and OPV devices. Well, let's have a look of some of the benefits of nano inks when compared to the traditional silver flake paste. Our smart ink range is 5 times more conductive and consumes 10 times lesser ink when compared to the traditional silver flake paste. Thanks to nano inks, our clients are able to make thinner devices due to its fine line printing capabilities, and they're also able to manufacture devices that are more flexible and more stretchable end of the day. Okay, so now we'll have a quick look at the introduction of the consumer electronics and its market and various applications in with regards to fine line printing. So consumer electronics are electronic equipments, as you all know, mainly for non-commercial use. Consumer electronics include devices that provide one or more functionalities, such as computers, laptops, mobile devices, smart wearables, TVs, refrigerators, smartphones, and home appliances. The consumer electronic market size was valued at over 1 trillion US dollars in 2020 and is estimated to grow at a compound annual growth rate of more than 8% from 2021 to 2027. Well, we see that a rapid increasing internet penetration across the globe will mainly drive the market. Let's have a look at the different consumer electronic products and the different applications in fine line printing. Consumer electronics is vast, as you can see on the photo on the left-hand side here, and the applications here mainly include narrow bezels, capacitive sensors, force sensors, ITO replacement, ultra-thin PCB interconnects, and solar cell circuits. In touch sensors or touch panels, the trend to narrow the bezel will not stop until the bezel vanishes. This trend has constantly pushed the requirements on touchscreen edge electrodes, narrowing the line width over spacing specifications from 100 by 100 micrometers to now beyond 30 by 30 micrometers. Fine line printing can also be used as ITO replacement by printing ultra-fine silver grids, and nano inks are the key to the success here. Well, let's have a look at the trends in the industry today, followed by the customer challenges. So to start off with the first trend, which is the COVID effect. COVID, as you all know, has played a big role in redefining the trends. The face-to-face physical meetings are of the past, and we have more and more new forms of interaction with the world, with social distancing becoming the new norm. Also, with many of them spending more time at home, has paved way for many companies to explore and exploit the huge sector of home gadgets and smart home technologies. Digital health and safety concerns. The pandemic gave a radical boost to the healthcare IoT technologies used mainly in the public health sector, but its influence on consumer gadgets is no less exemplary. Companies are moving to create more COVID infection detection kits and monitoring kits as demand for rapid lab-free COVID-19 testing has exponentially increased. Of course, the pandemic has also made a mask a new must-have accessory. While designers are working on making it part of their fashion collections, IoT companies and developers are enhancing this vital part of the new normal with additional functions. Before the global pandemic, the technology sector was developing at unprecedented speed. However, COVID massively accelerated the process like nothing else had before, and now we see that there's an increasing adoption for 5G. With millions of connections and data-intensive applications at a different level of power requirements, manufacturers expect 5G to quickly become the global wireless standard and accelerate the shift towards connected consumer devices. We also see a trend in development of the semiconductor industry. As you all know, with artificial intelligence and machine learning on the rise, the semiconductor industry is producing more chips which take electronics to the whole new next level. And there's also current trend mainly for environmental issues, where for the first time ever, countries appear to be more united in their decisions to address climate change, transition away from coal, and focus more on greener technologies. Consumer electronic manufacturers are responding to the sustainability concerns of investors. Thanks to this, we see a gradual shift to printed flexible electronics and nano inks, where the materials are more greener and the pollution created is considerably lesser. When it comes to the customer challenges, the biggest challenge they face is miniaturization of electronics. In consumer electronics, customers expect the devices to be smaller, faster, lighter, and connected. And the existing technologies or solutions out there don't necessarily reply to these needs. And this is where printed electronics have begun to address these challenges, notably nano-inks. Now that we had a look at the trends and the customer challenges faced in the industry today, my colleague Stephanie would take it forward from here and enter into more detailed conversation on fine line printing.
Yes, thank you, Rahul. So now let's move on to the technical part. In today's meeting, we will focus on screen printing. And first, let's see which parameters come into play for fine line screen printing. So we have 4 of them. The first one is the substrate. The surface energy and the roughness of the substrate will affect the wetting of the ink and so the final resolution. The second one is obviously the ink and especially rheological behavior of the ink. We'll see later that rheology and thixotropy can be modified to enhance resolution. The screen parameters are crucial to obtain a good resolution, and especially mesh count and diameter, which influence open rate, and also the material of the screen, stainless steel or polyester, and the emulsion type. And finally, the printing parameters are also very important. We will see details in the next slides. So let's focus on the screen and the printing parameters. So for the screen, a stainless steel mesh produces a more stable and accurate print because this material is harder than polyester. A high mesh count is required to obtain high resolution printing. The choice of mesh thickness, emulsion thickness, and open area should be done regarding the targeted printed thickness. Also, a hard squeegee is required for fine line printing. And finally, a high squeegee angle helps to transfer the right amount of ink. So a work must be done to adjust the quantity of ink transferred, enough to ensure a good conductivity, but not too much to avoid spreading of the ink. Concerning the ink, GenesInk has designed a ready-to-use solution for fine line printing, the Smart Screen R. It is non-CMR, solvent-based, and contains no binder, which ensures a high conductivity, even at low temperature. It is easy to process and easy to clean. What you can see here on this slide is a microscopic picture of a print obtained by with the Smart Screen R on a chemically treated PET with the Hasada mesh. Resolution down to 30 micron were achieved. So this ink covers a wide range of customer applications. But in some very specific cases, like for example, when using a tricky substrate imposed by a certain application, this ink can require a formula customization to achieve lower resolution, as we will see in the next slide. So let's move on to a customer case. We were contacted by a customer for a project for FPCB application. He had a target to print a 50 micron line resolution, but with a specific mask and also a specific substrate. And with these constraints, GenesInk Smart Screen R performances were not sufficient. So in that case, GenesInk's strategy is to work together with the customer through the customer pre-sale group team to find the best solution to this challenge. Indeed, GenesInk has created a team, customer pre-sale group, whose mission is to support customer through each step of its process, from the proof of concept to production, passing by raw material validation, prototyping, and drop-in validation, by doing printing tests and formula customization. We stick as closely as possible to real application conditions in order to find the most suitable solution for the customer application. So for our customer case, let's see how CPG works to adapt ink to the specific constraints of the customer. The work was focused on modifying ink rheology and simulating the screen printing process to improve resolution. What you can see here is a graph of viscosity over time when applying various shear rates to simulate screen printing. So at first, ink is at rest on screen, simulated by a low shear, and viscosity is high. And then the ink is sheared when pushed through the screen meshes, simulated by a high shear. And here a low viscosity is required to ensure proper transit through the meshes. And finally, ink is at rest on substrate, simulated by a release of shear. And this is a key part, because viscosity should recover the highest value possible in order to avoid spreading on substrates and ensure good resolution. So the aim here is to increase this viscosity value immediately after shear. Here you can see the several ink formula that we tested to increase the viscosity value after shear. We performed several iterations and finally ended with formula B, which has the highest viscosity after shear. So now let's see if this improvement of viscosity has led to an improvement of resolution. Here you can see microscopic picture of the printed lines obtained with the customer mask and substrate. We can see that for Smart Screen R, resolution was insufficient. And with Formula A, the resolution was improved from 82 microns to 66 microns. And finally, with Formula B, we reached 51 microns, which was the target of the customer. So this shows how rheological modification can improve resolution.
Thank you, Stephanie. Now, before we end this webinar, let's move on to the conclusion as to what we see from all of this. Well, the first and foremost important point is that fine line printing is the key to form factor reduction and to all the problems that designers face or struggle with regards to finding space in the electronics. And what we also see is that fine line printing opportunities are large for various electronic applications. And with progressions made in printed electronics, we know that the applications are just large, and we don't know all the applications as of today. And even though 85% of clients use screen printing technology as the most widely used, we could confidently say that fine line printing is not limited to just screen printing. You could also achieve fine line printing using inkjet or flexo. Nano inks are key for fine line printing, and they also address various issues faced in the electronic industry today. And GenesInk offers wide range of solutions. It could be off the shelf or customized to meet the client's needs and requirements. As you know, Stephanie gave a good example of a business case where the client was in big trouble and they had approached us, and within a span of few months, we were able to fine-tune the ink to meet their needs and requirements. And it's thanks to the proactive teams such as the CPG team that we have here at GenesInk, we are able to reply to all the needs of our customers with regards to fine line printing. So yes, that's the end of today's webinar. And before we move on to the question and answer session, we'll just have a quick 1 minute of questionnaire session where we would ask you certain questions, and I'll give you a few seconds to reply to it.